Hello students, welcome back to our channel. In this video, we are going to start our part 2 of chapter number 3, atoms and molecules. In part 1, we have discussed about all the topics like chemical formula, mass and constant proportion, Dalton atomic theory, then atoms, ions, molecules, chemical formula and molecular mass. We have done 8 topics in that part 1. In part 1, I will upload a PDF in description with short notes. I have made and short notes I will upload in description. So this is the part 2 of atoms and molecules chapter number 3. In part 2 we will do back exercise, and as well as we will do some questions of index. Okay, we will do some question of index. And you have if you want short notes and easily explanation, so I will upload this link of PDF in description of part chapter number 3, atoms and molecule part 1, as well as in part 2 I will upload. So let's do something. I will upload link of that PDF in part 2 only. Okay, so after this video, view the description and open the link and download the PDF. It will be very useful to you. I have made the notes, so view the description and download the PDF. Okay, I will upload in the description. So let's start with our chapter number 3, atoms and molecules. It back exercise. So let's do first question. What is that in first question? A 24 gram of simple compound of oxygen and boron was formed by analysis of content 0.096 gram of boron and 0.144 gram of oxygen. Calculate the percentage. Okay, we have to find the percentage. And how would you find the percentage? If you have 25 marks out of 30, you will do into 100. Okay, by this method you will find out the percentage. So by this method we will find out the percentage of this. What is the boron? Boron is given 0.096 gram. Then oxygen 0.144 gram. We have to find percentage of both of them. So first of all we will take out their mass. What is the total mass? 0.096, 0.144, 0, 1 carry forward, 9 plus 10 14, 1 carry forward, 2.0. So initially we got 0.24 gram, and it is given textbook also, but for our knowledge I have taken out that. So let's start boron. Let's start with boron is equal to, what is the total mass? Total mass is 0.24 into 100 and up and upward 96. We will do that also in oxygen. What is total? 0.144 upon 0.24 gram. Okay, 0.24 gram and into 100. So students, can you give me the answer in comment box? What is the sum of this and this? And first of all see the question and give me the answer in comment box. What you if anyone was giving a right answer, I will pin his comment. Okay, students, I hope that you have all written the answer. So I will write. When you simplify it, you will get minus 64. You can see 24 divided by 96. They can be divided because both are even numbers. Okay, even here both are even, so it will be easy for you to do. Okay, I got 40. So you have to calculate in your mind, and in this, obviously, if you are getting 40 over here, you will get 60 over here. How 60? Because total percentage of is 100 gram of solution. Total is 100 gram of solution, and if boron carrying 40% of 40% of a space, so fit obviously oxygen will carry 60%. So we have done our first question. Now let's move with question number 2. What is there in question number 2? Question number 2 is very easy. So let's do it. In question number 2, when 3 gram of carbon is burned in 8 gram of oxygen, it produces 11 gram of carbon dioxide. What mass of a carbon will be formed when uh, carbon dioxide when it 3 gram of carbon is burnt in 50 gram of oxygen? Okay, what they have said, 3 gram of carbon and 8 gram of oxygen, they form 11 gram of carbon dioxide, CO2. Okay, we know that law of constant proportion and law of conservation of mass. So when they plus 8 plus 3 11. Okay, so here the first rule is applied. The mass cannot be created or destroyed, and then they said 3 gram of carbon burnt in 50 gram of oxygen. What will be the ratio it will produce? 11 gram. Why 11 gram? Why I have said 11 gram? Students, why I have said 11 gram? Because we know the law of constant proportion. We know the law of constant proportion. If 3 gram of carbon will be burned with 50 gram of oxygen, it will produce another compound or another molecule. It will form another compound or another molecule. Uh, if suppose I take 3 hydrogen atom and 1 oxygen atom, water will not produce. We all know that. If I take 4 sulfide and 1 oxide, so it will not produce sulfate. Okay, it will not produce sulfate. So we know that the law of constant proportion. So 3 gram of carbon will always burn, always and always it will burn in only and only. Okay, 3 gram of carbon will burn with only 11 gram of oxygen. If it will burn with whole 50 gram of carbon oxygen, it will produce another compound. It will produce another compound, not CO2. So that means 3 gram of carbon burn with only 8 gram 8 gram of 8 gram of oxygen to form CO2. And students, this is very important, and another 42 gram of oxygen, another 42 gram of oxygen will be unused, wait for 2 minutes. will be unused. So I am highlighting the keywords. I am highlighting the keywords. This 42 gram of oxygen will be unused. That means when a carbon is burnt with 50 gram of oxygen, it will use only 8 gram of oxygen, and another 42 gram will be unused because it want carbon want to form carbon dioxide, so it will only react with 8 gram of oxygen and another 42 gram will be unused. Okay, and the 11 gram of carbon dioxide will be produced. So we have done our question number 4. Sorry, question number 2, not question number 4. Let's see question number 3. Let's see question number 3. After doing question 5, 6 is very easy. 6 is very easy. Okay, 6 is easy, but also we will do that, and let's do with question 3. What is question 3 saying? They have said what is polyatomic ions and example of it. The polyatomic ions are a group of atom having charge is known as having net charge. Not charge, net charge. A group of atom having net charge is known as polyatomic ions. Okay, students, this is known as polyatomic ions. So you can see the definition: a group of atom having net charge. That means we know that we know that any atom having charge, any single atom having charge, we know that it is known as ion. Okay, and any atom having not any charge, we will say only atom. If any atom if any compound having net charge, when the two elements mix together, the electron configuration will be used, the electrons are loose or gain. So if any compound having net charge plus or minus, they will be cation or anion. Okay, any group of atom, that means any group of atom having net charge, not a neutral, having charge, it is known as polyatomic ion. We know that in maths you have learned that linear, no, not linear, monomial, binomial, trinomial, and polynomial. So here also polyatomic ions, it is known as polyatomic ions. That means three more than 4 atoms, more than 4 or more than 3 atoms. Only single atom is known as tetratomic. Then second is no, if having 2 atoms, it will be known as tetratomic. 3 atoms, it is known as tetratomic. And the if any atom, any compound having more than 3, it will be known as polyatomic ion. Okay, I hope that you have understand what is polyatomic ion. Any group of atom, that is compound, any group of atom having net charge, it is known as polyatomic ion. Okay, so let's do with their examples. Which are the examples? Okay, these are the example. Okay, students, these are the examples. Oxide hydrogen. Okay, oxide hydrogen carrying minus charge. You can see the every group of compound or molecule having any charge on them. So it will known as polyatomic ions. Polyatomic ions. See students, there are one, two atom. It will in oxide and hydrogen there are two atoms. So more than three. One atom of sulfate and four atom of oxide. So more than three, it is known as polyatomic and having charge. So polyatomic ions. Then one atom of carbon and three atom of oxide. So it having charge on it. So it is known as polyatomic ions. So let's continue with our exercise on question number 4. Question number 4. I will do some hard and easy. I will give you homework. Let's first of all do first one. Let's start with question number 4. So students, we have question number 4. We have to find the chemical formula of magnesium chloride. So magnesium is denoted by Mg and chloride is denoted by Cl. Now, what is the valency? Okay, what is the valency of Mg and Cl? Valency of Mg is sodium, magnesium, 2 valency, and chloride valency is 1. We will do crisscross method. This method is known as crisscross. So we will write MgCl2. This is our answer. MgCl2. M we will write capital. MgCl2. Okay. Now let's do second. Calcium nitrate. You have to learn the valency as well as the symbol. They have given in table 3.6 and 4.1. Just remember that all. Calcium is denoted by Ca and nitrate is denoted by NO3. Valency. Okay, there is some mistake in question writing. So here calcium oxide is there. Calcium oxide. Okay, as I told you that if one atom is having charge, it is known as monatomic. If two atom having charge, diatomic, three tetratomic, and if more than three, it is known as polyatomic. So that's why oxide is known as that is from ions. Oxygen convert into oxide because it become ion. And why oxide? Not remember O. Why we written oxide? Dioxide, not monoxide. Dioxide. It means two atom having charge. That means oxygen convert into oxide. It convert into ions, and there are two atoms of oxide. So it is known as dioxide or oxide. Okay, oxide. So it is denoted by O. The valency is 2. The valency of oxide is also 2. We will do crisscross method. Ca2O2. These two will cut because we can take common CaO. Okay, this is the answer. Now let's move with C, and remaining two I am giving in the homework. Okay, you have to do practice of this. This is like maths only, not hard, but you have to do just practice. Now let's do E number. E is little bit hard. Calcium carbonate, calcium carbonate. Calcium is denoted by Ca. Valency is the valency of calcium is 1. No, sorry. Calcium of valency is 2. Okay, and the valency of carbonate is denoted by CO3. CO3 is denoted by carbon. Okay, valency is 2. We will do crisscross. CaCO3. 2 will come out common. Okay. So I hope that you have understand in chemical formula. I have also given some examples in part 1 in explanation part of this chapter. So let's begin with question number 5. I am doing some questions and remaining I am doing 2 questions and remaining 2 are in homework. Okay students, remaining 2 are in homework. Let's do question 5. Let's do A. Quick lime containing calcium and oxide. Quick lime is made up of calcium and oxygen, but oxygen converted into oxide because it has a charge, so it is known as ions dioxide. Okay, so quick lime carrying CaO, so it will become CaO. Now let's do C. C is hard, but B and D just like the question number 4. Baking powder. In baking powder, there are two main compound. One is sodium and second is bicarbonate. Sodium bicarbonate is present only in that. What is baking powder? Only sodium is denoted by Na and bicarbonate is denoted by HCO3. Carbonate and hydrogen is known as bicarbonate in solution like this. When you will attach to both of them, we will get NaHCO3. NaHCO3 will be your answer. Now, remaining 2 I am giving in homework. Both are very easy. So let's begin with question number 6. Let's do question B. B is little bit hard. S8. B is S8 and 8 is atomicity. So what is the mass of there are 8 atoms of sulfur. 8 atoms of sulfur. So mass of sulfur is 35.5. Am I right, student? 35.5? Wrong, students. Not 32. Okay. The mass of sulfur is 32 and 8. We will multiply by 8. What will be the answer? Comment your answer. In last, I will write answer. Now let's do C. They have given the mass of phosphorus P4. What is the mass of phosphorus? 31st into 4. Comment your answer. Let's do. I will write answer. Don't worry. But first of all, you comment it. Remaining all are very easy, students. Remaining all are very easy. Let's see D number. HCl. The mass of hydrogen is 1 and mass of chlorine is 35.5. What you will get? 36.6. You will get 36.6. Now any of them are easy or hard? Let me see first of all, then we do the answers. Okay, so remaining all are the easy. So let's do. When you multiply 32 into 8, 8 2s are 14. Oh, sorry, 16. 1 carry forward. 8 3s are, what is 8 3s are? 24. 25. 2 5 6 gram. Okay, students, this is the molecular mass. This is molecular mass. In atomic mass, atomic mass, that means proton plus neutron, you will put U, but in molecular mass you will put G, gram. Now let's see this. 4 into 4